and welcome to my session, Open Source as a Factor of Trust. I'm Hendrik, I'm from Germany, and since several years I'm part of the open source community. I'm member of the Eclipse board. I work in working groups and steering committees at several Eclipse projects and working groups, like, for example, Adoptium. I even work on the Linux Foundation, where I'm leading the TSC of the Hybrid project. And I have my own company, which is Open Elements, that I founded with like the focus on open source and Java. And currently I work a lot for Hashgraph, which is a company coming from the sector of decentralization and distributed ledger technology. And that is actually where this talk about. So I would like to talk about distributed ledger technology and how important open source is for distributed ledger technology to create the trust that we need to really use those technologies. So since I assume that a lot of people do not know in deep what distributed ledgers are, what is all behind. A lot of people maybe heard a lot of buzz, all those NFT stuff and things like that. But I always coming from another point of view when talking about distributed ledgers. I'm coming more from the enterprise point of view and why it makes sense to use it in enterprises. And I would like to give an introduction with that. And saying so, I would like to start with a real world use case and a real world sample. So let's assume you live in South Africa and you want to transfer money to a person that is living in South Korea. Maybe it's your mother or something like that. So to be more concrete, maybe you have an account at the Standards Bank, which is like the largest bank in Africa, and maybe the other person had an account at the Shinhan Bank, which is a leading bank of South Korea. So what do you think how much it costs to do a transaction of money from bank A to bank B? Any suggestions? 50 euro, 15. 50. Yeah, that's quite near. And what do you think, how long does it need to have the transaction done? 2 business days. Yeah, it's worth. So those 2 banks checked it out, and they figured out, like, doing a transaction so starts with $40 of fees that you need to pay to send money from a private account to another private account between those banks, and it takes up to 6 business days, right? Not days, business days. So if there's a weekend in the middle, oh yeah, you can wait really long for the other person to get your money. And since it's so long, it's really a problem that you cannot track it. So you create like the transaction on your side, and then for 6 business days, nothing happens. And you have no idea what the state, where the money is, and so on. And that is quite a problem, right? And when I heard about this, it was like, whoa, I had no idea that we still have those processes, right? Because especially in banking, I assumed everything is digital. So the problem that we have here is then when doing such a transaction, as you can see in the picture, there's no direct connection between those 2 banks. So instead of having just one transaction, those 2 banks, since the transaction goes over a lot of borders in the world, going from Africa to Asia, you have like middlemen, other banks, where this transaction goes over. Those are not private banks, those are like really global, I just called it here global mega banks. I don't know if there's an official name for those. But as you can see, there are really a lot of transactions, and those are not connected, right? So you really have like manual work maybe between those transactions and so on. So that is a little bit of problematic. And what those 2 banks did, based on that scenario, they tried to create a better solution by using distributed ledgers. And what they did is they create a proof of concept with Hedera that has been released last year, so this proof of concept. And they used the Hedera network, which is a product, it's one network that is using decentralized ledger technology to create those transactions over a decentralized ledger. So how have they done that? So both banks were connected with the Hedera network, and what they did is they created cryptocurrencies. So no cryptocurrencies like Bitcoin that you, like with your mobile, can trade or something like that. They created a cryptocurrency version of the South African rand. They created a cryptocurrency version of the South Korean won. And what they did then is they exchanged more or less half of it. So that both banks have cryptocurrencies or have a stock of cryptocurrencies of both of them. And now whenever a transaction happens, it's just a transaction that is triggered on the Hedera network to do that transaction with those cryptocurrencies. And by doing it like that and having this, flow over the Hedera network, they were able to limit the fee up to 10 cents. Actually, those 10 cents already include the fee of the banks. So doing the transaction on the Hedera network is way cheaper, so they already do money with that. And it's less than a minute, the whole process. So from having the bank, the money from account A to account B, and it's really trackable in real time because you can track all the transactions going through the network. Oh yeah, and it's provided all the time. So that sounds easy, and people can directly say, yeah, you put the Hedera here in the middle. I mean, you could put a server here in the middle, a database, something like that, right? So why do you talk about distributed systems in this case? The point is, it's about trust. Because we currently have two banks with transactions that might involve a lot of money. And so I never said that those two banks do not trust each other. I'm not saying that they trust each other. I'm not saying that they do not trust, but it's not defined, right? And they interchange with data that, is like worth real money. You really need to create trust. So let's see how that looks. Let's assume we have two companies, independent if it's a bank or something else, right? And those companies have this super common use case that we have everywhere in our industry today. So what they want to do is they want to share data. They want to exchange data between each other. And whenever you do something like that, you need to make one important definition, which is who owns the data. Because when you exchange data between companies and you do not define who's the owner of that data, how do you behave if both companies have different data sets? If you compare them, there's a difference in it. If you do not define which one is the master, like the owner, you have a big problem, because then your whole data set is broken and useless anymore. So what you need to do is you need to define an owner. Coming back to the scenario of the two banks, maybe as a bank, you don't want to say, oh yeah, there's another bank in another country of the world, and that owns part of our money. It's problematic, especially since having this like one owner, it's possible that data can be hacked, mutated, and things like that, right? So when we talk about exchanging data, sharing data, in general, that always, and we are not able to define like one host, one owner of the data, that is always a problem. So what we need to do, we need to kind of like externalize the ownership, right? Let's say that is something that we could do. So let's assume there is a company, Trust Inc., and they own the data, right? In that case, neither company A or company B owns the data. Both cooperate with some APIs or something like that provided by Trust Inc. Both have the same rights to read the data, mutate the data, and so on. So now neither company A or B owns the data, and between those companies, there can be a trust, right? But there's still another problem with that. Because, so who controls the owner, this trust ink now? That can be like a very shady company that can do whatever you want to with that data, right? And that can really be a problem. So they can actually change all the data, sell it to somebody else, and your company is bankrupt, actually. So, and that is definitely not what we want. So, and a solution that has been established within the last years is what we call decentralized trust, so that we use decentralized systems to share the trust. And I will give you an idea how that works. So we all knew distributed systems, right? That is how things are work these days. Different people, different servers, nodes, clients, however you want to call it, work together. Those systems can grow, you can scale those systems up to a size, you know, where they are really huge. You have a lot of nodes all over the planet. And as people now learn in university, and most of us know from our job, when we have distributed systems, there are two nice facts about it, which is scalability and fault tolerance. So fault tolerance means if we have 10 nodes and one node explodes, the system still runs, right? Because we still have that 9 nodes that are running the system. That is what we understand with fault tolerance. When it comes to scalability, what we often think about is like, when thinking about microservices, so we have like 5 microservices, stateless servers, behind a load balancer, and those are running our, I don't know, online shop. And then it's Black Friday, and thousands, hundreds of thousands of people come to our online shop, wants to buy things. What we can do is we can scale up the system, and that makes the system faster. Because in a stateless system, every transaction that comes in is handled by one node in the system, and if you have more nodes, you will get way more transactions that can be handled. The important point is, when talking about distributed ledgers, exactly that point is wrong. That is, for distributed ledgers, not the case. While we have fault tolerance, we do not have an increase of load or performance by increasing the scalability. Because in a distributed ledger, every transaction that comes to the system is executed by each and every node of the system. So if we have a system which, 1, 2, 3, with 6 nodes, and a transaction comes into the system, all 6 nodes execute that transaction, right? In stateless microservices, one node will execute the transaction, gives the result, and all the other nodes have no idea about the transaction that it even happened. And here in a distributed ledger, every node executes every transaction, which means if we add a node, we cannot execute more transactions, because all the nodes still execute more transactions. It's now one additional node that, in addition, executes all the transactions coming to the system. And what that must do is, when talking about scalability, that makes a network more trustful. Because let's assume in one node an error happens. Maybe there's an out of memory or something like that, and maybe a transaction is handled in a bad way and has a broken result. If you have like 10 nodes and it happens on one node, then you have 9 nodes that still have, the right result, and that will define the state of the system for the future. So when talking about trust, I mean that the state of the system will be more trustful by adding more nodes. So as said, fault tolerance is the same. One thing I won't talk today, because we do not have that much time, and I will want to come to this open source topic of all of that. When talking about distributed ledgers, it's quite important to have a consensus mechanism that, like, after each transaction defines what is the consistent state of the network, right? As I said, maybe one transaction is broken, has bad data, maybe somebody hacked in, and we have a bad node, and that could create bad result. We need to have a consensus mechanism that defines, at the end, what is the safe and solid state of the network, and in worst case, excluding nodes because they do bad stuff. And that is an area where, starting from Bitcoin, where it was like proof of work that cost a lot of resources and power, a lot happened within the last years, so that we're now on a state that we can really use those networks in a sustainable way and do not, like, need the power of a whole country to run such a network. And one network, we already seen that in the example, and to show you, or to make more clear what it does and why it's interesting for enterprises, is the Hedera network. Because, so when talking about Bitcoin, for example, every person can run a Bitcoin node, right? If I personally could run a Bitcoin node and be part of the network. If I'm a country, I could run 1,000 Bitcoin nodes and be part of the network. And if I have enough resources, I could even take over the network, because I'm running like 75% of all nodes, and then what I do is what the network does. And what Hedera does is a little bit different, because they have a council, and as you can see on the slide, there are a lot of well-known companies that are part of the council: Deutsche Telekom, IBM, Google, the banks we've just seen, Boeing, and so on. So companies from different sectors and from different countries of the world come together, and those companies form the network. So each of those companies run one node, exactly one node, so that the trust of the network is split between all those companies, which means to harm that network and harm the state of the network, like 70% of those companies from all over the world need to do an evil master plan to destroy that network. So something that only can happen in technical theory, but not in practice. So, and coming back to our two companies, so what they can now do is they can now interact with such a network by doing transactions against the network. And by doing so, the state is stored in the network, and none of the two companies is owning it. Even better, if they want, they can become part of such a network. And being part of it means they even like part of the trust of the network. So that is one part that is important for trust, but there's another one, right, which is openness, transparency, and open source. So having such a network where I, as an maybe individual, as an entity, as a company, want to interact with, store data, and so on, to do transaction against, it's absolutely important that this thing is auditable, that I can check that it's secure, that it has some kind of standards, so that even if this software goes down, I do not in a vendor log in and can move to something else. I would say like all those things that are interesting for open source projects are really important for such a system. As is the supply chain security. So there are a lot of sessions about supply chain security here at the conference. And for such a network, it's like for everything else, super important, right? Because you want, again, to trust that network, and you can only trust that network if you know what is running in the network and what is deployed in the network, which means we have different attack vectors when it comes to supply chain security. I assume you've seen those slides several times already. And the good thing is that in the open source, especially in open source foundations like the Eclipse Foundation with the Open Regulatory Compliance Working Group, or in the Linux Foundation with OpenSSF, foundations started to work on exactly those topics. And those topics are coming more and more to the buzzword Web3 ecosystem. And one important thing happened actually last month. That was the creation of the Hiro project. And now I come back to why I used Hedera as a sample in the slides before. Because the Linux Foundation in September created the Linux Foundation Decentralized Trust, which is a kind of working group for all decentralized trust ledger technologies. And one of the big projects of that working group is Hiro, which is the source of the Hedera network. So Hedera has moved all the sources, transferred all the sources to the Linux Foundation to make the source of the Hedera network vendor neutral, which means with that move, we do not have like a product that does a lot so that you can use it in a trustful way. It's even defined as a vendor neutral project now, and Hedera, the product, is just one product that is built on those sources. So in theory, you can now use the sources and create your own private decentralized network. Maybe if you're in a specific sector and want to exchange data with some other companies, you can use that. Everybody creates a node, and by doing so, you have like a private network that you could use to exchange data in an open and trustful way. So I often talked about, oh yeah, it's a network, and you can do transaction against it. So what is it really like? So how to interact with such a system? Is it kind of a database? Do I do something like SQL requests against it? Is it like a server? Do I use REST or something like that? Actually, when coming to this decentralized systems, the idea to interact with them is mostly using something which is called smart contracts. And when you heard about this the first time and read the first article about it, it's a lot of confusion. But when you break it down and remove all the buzzwords and stuff people talk about it, it's quite easy. Coming back to our real-world example where I started the talk with, right? These two banks that use the Hedera network. So what they did, they have a smart contract that is deployed to the Hedera network. And a smart contract is nothing else than a program, right? You can think about it like a stored procedure in SQL, but it's way, way more. Because a smart contract is executed in a virtual machine that is running in those networks. So there's a distributed, decentralized virtual machine that is running in the network, and you can think about it as a state machine, right? So whatever you can do with the program, you can do here. You can create, I don't know, any data structures, a map or something like that, and create functions, getter, setter, and so on. And then you can call those functions and change state within the network. So you can define your data, like you can define a map and say like, okay, I have users and some user data, and I create some method how to interact with those map, and then the players or the partners I cooperate with can easily call methods of that smart contract, and those methods will automatically executed on each and every node on the network, so that at the end, the whole network has a solid state and every node has executed it. So I don't want to go deep into how a smart contract looks like, but that is an example. That is, you know, I just created a fake coin example where I have a balance and then I can send coins to some account and things like that. That is actually like the easiest crypto coin you can think about it if you want to. It's not safe because everybody can then use it and just send money and things like that. But that is how a smart contract looks. And that is really deployed to the network. And what you can then do as a user, you can, for example, call the mind or the send functionality. As you can see, there are some requires in the first line of each method that is to check the rights of users, because not everybody should be allowed, for example, to send money. You should be only allowed if you have money and things like that. But it's really like easy as that, and you can deploy that to a ledger, and then both parties can work with it. And again, here, it's important to have trust, right? Which means a smart contract normally should be open sourced. And if it's something in it where you say, oh yeah, I don't want to give that out to the public, you should at least share that smart contract with your partner, with that you are using those smart contracts together to exchange data, because by doing so, your partners can audit it, they can check, is it secure, are there any problems with it, and so on. But by doing so, there can be one problem, right? So even if such a contract is open source, coming back to our supply chain security, there's this point at the end where you need to deploy it to a network, right? So, and how do I know when I work together with a partner and that partner deployed that contract to an high network, how do I know that he do not deploy something else? I mean, yeah, I see that code in an open source repository, that is fine, but you build it, you compiled it, and then you deployed it to the network. I see it's the same method names, and I can call the method, but how do I know that you do not change the method and something bad happens, right? So that you maybe just at deployment time deployed an evil binary instead of the binary that would come out when you compile the contract. And here one important thing is reproducible builds, because whenever you compile a smart contract, you get a binary that is then executed in the virtual machine, in the network. You can think about it as in Java, right? You have a Java class, you have a Java file, you create a class file out of it that contains binary code, and you execute that in the JVM. It's more or less the same here. You have source code, you create binaries out of it, and deploy and execute it in the network. So the important thing is, and we can finally do that since sometimes, that those contracts need to be verified. And Project Hyro provides exactly this, so that you can verify deployed smart contracts at one time based on this check of reproducible builds and things like that. We have an API that you can use to programmatically and automatically check that a smart contract that is deployed on the network is based on exactly those sources. And there's even an UI where you can do it by hand, and you can upload the sources and the binaries and do a verification check. And once it's done once, you see it in your UI as verified. But that is more like to play with it. The real idea is to do it automatically, right? Before I want to work with that contract, I check if it's really the one I assume to. So putting this all together, what does it mean in case of distributed networks that are based on open source components? So again, if we have two companies that want to exchange critical data, it's often a problem. So what we can do, instead of having a direct connection between those, we can use a decentralized network. For example, the Hedera network that is based on Hyro, where in that case we have over 30 entities, so over 30 nodes that define the network, coming from all over the world and from even different sectors. Like here we see tech sector, banks, IT, and so on. Based 100% on open code, so you can verify the code of the nodes that are running in the network, and you can audit it. Coming since last month in a vendor-neutral way based on the project of the Linux Foundation, which is Hyro, with a critical view on supply chain security, where I have happily learned so much in the Adoption project, and I was able to bring it into this one too. And within this network that is now based on all that facts and components, quite trustful, we can deploy code, a smart contract, that we can share with our business partners, the code, or in a best case, even define it as open source smart contract that is hosted at GitHub, that contains our business logic, maybe our data specification to exchange data between companies. And we can even, the deployed one, we can even verify that automatically if we want, to check that it's exactly what we assume, and we can safely work against it and exchange data over that way. So what does it mean? So when coming to that, so one thing that is quite important when we want to create this trust of working together and exchanging data is transparency, right? Even if it's open source or if we share contracts only with our partners. It's supply chain security, actually, because even if it's open source, we need to make clear that what we see in the open source is really what is deployed in the network on a node basis or on the basis of a smart contract. It is decentralization, because if we only have like one node or not a network at all and work directly together, then we always have the problem that somebody can harm the data. It's only one person needed or one entity needed to harm the data. And it's vendor neutrality, because you do not want to have one party who controls everything, even if it's open source. You want to have like a group, like a working group of an open source foundation that controls all that and makes clear that if there is a problem, nobody has a benefit out of it, right? So it's really the community coming together to create it. And yeah, from my point of view, it's open source because by having all that open, we can always audit the sources, we can see are there any security issues, we can even hire external companies that audit, people can open issues if they see a security issue, all that. So that is what I would define is needed to create a trustful exchange of data over distributed ledger technologies. And I still have 2 minutes, actually. I was assuming I'm even over time, but that's good. I have 2 minutes left. So I hope you liked the introduction of how you can use all those decentralized technologies in enterprises away from all this NFT, PNG picture, buzzwordy stuff, and how it's connected to things like open source and supply chain security to create a system that is really trustful to exchange critical data and critical data structures, actually. That's from my side. Is there a question from the audience, actually? So it's 1 minute left. Okay. So there's no question from the audience. Then, oh yeah, there's a question. Yeah. Okay. So the question was how storage intensive are smart contracts. So there are 2 things you need to think about. So having the network, and in the network, let's say like in the memory of the network, you have the current state. And once a transaction happened, the state changes. So in a node, you do not have like a history of everything or something like that. But what we are doing, we create a stream of records. Like for transactions, we have a record transaction stream. And that one is currently stored, is it AWS or Google Cloud, I don't know. So like in a very huge storage, And yeah, that storage is growing and growing and growing exactly because, and that is actually, I mean, a lot of people talk about blockchain when talking about that technology, right? And that is a blockchain. So like all the nodes, all the smart contracts, things like that have nothing to do with blockchain. Where the blockchain comes into play is when we store the transaction log, because there we have a blockchain that always can verify itself, so that when a node comes up, what it gets is a snapshot. So we do like from time to time snapshot of the current state. And then he needs to execute from that snapshot on the transactions from the transaction stream to be on point. And yeah, it's growing. So it's not the node, it's one system that is growing that we have externalized. And currently it's still handleable. If in many years, you need to say like, oh yeah, we now need to wrap like those previous states together. That is something that will be seen in future. But actually, with Hyro and this idea for Hedera, it is growing. But if you, for example, say, oh yeah, I create a private network with 3 partners, then you do not have that problem, right? Yeah. Okay. Now we're over time. Thanks again for attending my session. Yeah, and if you have any additional questions, see you around.